Hello everyone, welcome to our YouTube channel Metallurgical Engineering. So in this today's video we are going to see 10 objective questions on heat treatment. So the first question is, when heat treating a steel alloy containing 0.4% carbon, what would be the primary goal for tempering after hardening? So as you know that when you are doing hardening process, so it will increase the hardness of the material, but at the same time it also decreases the brittleness, it also increases the brittleness in the material. So that's why we need to do the tempering process to reduce the brittleness and also to increase the ductility and toughness. So here if you can see the so there are the four options. First one, to increase the carbon content on the surface, wrong. To decrease the electrical conductivity of the alloy, wrong. To increase the brittleness and increase the toughness, this is what tempering will do. So the correct answer is C here. Now let's go to the second question. In case hardening, which element is primarily added to the surface to increase the hardness of the material? So basically in case hardening is a surface heat treatment process which usually uses carbon. So here the correct answer is carbon here. Now the next question is, during carburizing, what must be controlled to ensure proper diffusion of carbon? So as you know, the carburizing is again a surface treatment process. So in this case, the main two parameters which can be controlled, that is temperature and time. So if you can see the option here, so C option is here. So the temperature and time must be controlled to ensure the proper diffusion of carbon in the material. Let's go to the next question. Which of the following is not a typical outcome of annealing process in steel? So when you are doing annealing of a steel, so what could be not a typical outcome? So you can see option is softening of the material. So this is the outcome of the annealing process. Increased ductility, yes, this is also an outcome of the annealing process. Increased a reduction of the brittleness, which is again both are same thing. The fourth option is increased hardness, so this is wrong. So basically the D option is correct here. So this is not the outcome of the annealing process in steel though. So we usually do annealing to soften the material, to soften the steel or metal, to increase the ductility, to reduce the brittleness. Now the next question is, what is the effect of tempering on the internal stresses of a hardened steel component? So as I discussed in the first question, tempering is usually used to reduce the brittleness and also to reduce the internal stresses. So here the options are increase internal stresses, wrong. Has no effect, wrong. Reduces the internal stresses. So the correct option is answer is C here. Now the next question, which heat treatment process would you use to harden the surface of low carbon steel while keeping the core ductile? Again, it is talking about some kind of surface hardening treatment, surface heat treatment process. So here in the option, if you can see, annealing is not surface treatment process, normalizing is again not, periodizing is again not. The correct option is C, which is case hardening, which can be useful to harden the surface of a steel and at the same time the core will be ductile. What is the primary difference between normalizing and full annealing in terms of cooling rate? So as we know that annealing, when we're talking about the in terms of cooling rate, so annealing has the lowest cooling rate and then normalizing, then hardening. So based on that, if you can see option here, normalizing uses a faster cooling rate, which is and while annealing cools very slowly, so which is correct here. While other option, annealing uses faster cooling rate, wrong. Both process use the same cooling rate, wrong here. Normalizing require quenching in water, no, it is wrong. Quenching in water is for the hardening. So here the option which is correct is A. Normalizing uses the faster cooling rate as compared to annealing. And usually and this full annealing will done in the furnace and the normalizing will done in the air. Next question is, which is 8. What microstructural feature is formed in steel when it is cooled very quickly from austenizing temperature? So as you're talking about, let's take an steel here, which is a 0.8% steel, which is eutectoid steel. So the temperature which is here is, the critical temperature is 723, which we also called as AC1 here. And when you go to the above the austenitizing temperature, so like let's go into the austenite region, heat till to the austenite region and hold for some time, and then you can quench. There is one option. You can do moderate cooling, which is another option. You can do very slow cooling, which is another option. So the quench will always provide a martensite. The very slow cooling will always provide a perlite, and the moderate cooling will provide a bainite here. So the correct option here, which is can cool very quickly from the austenite, is martensite. So the correct answer is D here. Now let's go to the ninth question. Which heat treatment process would you use to produce a microstructure that consists primarily of bainite? So here is a very famous heat treatment process which we use usually called ash tempering. So the correct answer is C here. And another one, this mar tempering will give us martensite. This full annealing will give us the perlite. And when we are talking about, this is for the 0.8% eutectoide steel. And normalizing will also give the perlite. So now the question comes, what is the difference between full annealing and normalizing? Normalizing will usually give us a coarse perlite, and full annealing will normalizing will give us the fine perlite, and the full annealing will provide us the coarse perlite. Here the correct answer is ash tempering, which will provide the which consists of primarily of bainite. Now the last question of this MCQ series is the transformation of austenite to martensite during quenching involves. So there are a few options: diffusion of carbon atom, no; formation of perlite, no; grain growth, no. So the correct answer is B here, which is a shear transformation without diffusion, because you are not giving a proper time to diffuse the carbon into the matrix, which is iron here. So that's why this quenching will provides as the shear transformation without diffusion, which results into the martensite structure. And as you know, the austenite change into the martensite, there is a crystal structure is also changing from FCC to BCT. While if you are coming from austenite to perlite, this perlite in this if the cooling rate is very slow, in which case it will provide us the BCC. So that's where this, if you are not giving us giving the proper time to diffuse the carbon into the iron atom, that's why this crystal structure change has been observed, that is body centered tetragonal. So here are the 10 questions for the heat treatment. As you see, if you have any doubts and if you want to further explanation for any questions, you can write down into the comment section. We will come to with the another MCQ series in upcoming days. Thank you so much for watching.